3 for us here and really talk about some of the things in Chapter 4. Also, Chapter 4 is going to go quick. We're going to look at the math package and not much more programming constructs in it. I have the programs for Chapter 3 and Chapter 4. I'm going to put one set of programming assignments out for those. That you use both the math functions and the if statements. Okay, so just give me a tonight / to Saturday to get those out. And I'm working on grading the stuff that's coming through. If anyone's having a problem submitting anything or needs a submission reopened, email me. Okay. Okay.
Okay.
All right. So let's make this work here. All right, so one of the things that we have to get and we'll see that we'll need more use of, is that we're going to have logical operators that can operate on Boolean data. So Boolean data is either true or false, and what happens is we can get these operators, just like mathematical operators, to change the Boolean algebra. Again, for the CS majors that go into discrete mathematics, you'll get a whole thing on Boolean algebra and how we can manage Boolean algebra. In general, it lets us combine things with ands and ors. It lets us take the opposite of what we have with a negation. This is very, very important. Just like when we needed to do a comparison with equal, we had to use the double equal sign. And is the double, what is that, ampersand? And or is a double pipe. It's two of them. If you use the single version of it, it's what happens internally on the bit circuits. So if I have, I'll just do a 4-bit word. So 1, 0, 1, 1, and 0, 0, 1, 1. And I do a singular if this is A and this is B, and I do A and I do a singular and on it. That's more like a G clef, isn't it? I'll just do that. What this does is on a bit operation, it says if both of these are 1, I keep that. If both of these are 1, I keep that. If both of these are 0, if I have a 1 and a 0, and it gives me a new word out of it. So if you accidentally use a single one, it will do a bit operation on you. Then let's see what A or B, singular. That's a 1, that's a 1, that's a 0, that's a 1. So it does it on a bit. This is kind of what the computer internals do. It's actually very useful things for when you want to. I can sometimes take a binary word, and I can make, instead of this being the number 0 or 1, 2, 4, or 8 in binary, I can say this will be, I can make these flags. And so 1 is on and 0 is off. And so I can look to see, what's a good flag? I could encode, let's see. I get things I like on or off. I just completely lost on or off things. I know within one of the guitar pedals I have, we have a bit mask on it, and it determined if I'm using resistor 1, resistor 2, capacitance 1, and capacitance 3. And so there were switches, and you could turn these things on or off in the path. Yeah, you can turn on and off values. This type of comparison on a bitwise runs a lot faster than software comparison on things in memory. Because your CPUs are built to check things bitwise, and your compiler will compile it. But for us, we want to use double. So let's look at what we get when we have these. So if I have a Boolean value, is this visible?
Yep.
All right.
Yeah, I can see it.
So if I have a Boolean value called Ralph, and I set Ralph equal to true, and I have a Boolean value called Maurice,
His father's name.
and I set Maurice equal to true for right now. Then I can use these in comparison. So if I can say, if not Maurice,
Oh.
so, well, Maurice is true, but not turns that into false. So this would be false. I can do a comparison on what the opposite is of whatever the value I have. So you could have Maurice being some type of flag, as long as Maurice was true. Remember how we used in our while loop, we used a go command, right? We could say, did the user enter, get it correct, right? We could have made the variable correct, so it read right. Correct was true, right? We were going into, and then we say, if not correct, keep going. And so we could keep our variable kind of reading in English properly. Does that make sense? That we can get, hey, I want this actually when this thing is false instead of when it's true. Okay, so the not operator is really nice for that. And conditions mean that for an and, both things must be true. So right now,
Makes sense.
if I do if Ralph and Maurice, well, they're both true, so that will be true. But if any one of them is false, then the whole thing is false. Yes, Jan.
So then, would or mean only one of them will have to be true?
No. Logically, and we'll talk about that. That's why there's two types of wars here. Okay? But for and, both have to be true for truth. If one is true and one is false, it's false. If both are false, it's false. Yes,
Can you
Hansi.
keep writing? Can you write on the whiteboard? Because I can't see it under the third line.
Got you. Cause damn monitor.
Yeah.
Yeah. What I want is I want my tablet working in here, and I want them to split the monitors so I don't have to. But we do what we do. I apologize, Hansi.
That's fine.
All right. So JM asked about or. So what we tend to do is we make truth tables. So if I have a variable, and I'll just call Ralph and Maurice here, and all the possible values they can have, true, 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 false, false, true, false, false, right? That's all the possible values those two booleans can have, because it can either be true or false. Then we'll look at and first. And is only true when both are true. So any of these results, right, will give me false outputs. So for an and to work, everything needs to be true. And that could be sometimes a good thing to check for if you're checking to see that data is within a certain range, right? You want X value to be greater than 0, but less than 10. If X is greater than 0 and X is less than 10, you're only going to get truth if you're in the middle of the range there. So that's how we can use it to work on things. All right, for or, both things are true, it's true. If one thing is true, it's true. If if both are false, it's false. So I just need one bit of truth in here. That's not how we use or in language, though, right? We'll sometimes say it's either this or that. And so to fix that language, we have a thing called an exclusive or. And with an exclusive or, if both things are true, right, here's my original things, if both things are true, it's false. Because it doesn't have that exclusiveness to it.
Oh.
There's one being true, one being true. And so that's what the truth table looks like. If you get these particular values, these are the results you get. Does that answer your question kind of like in the English language of how or works?
Yeah.
Yeah. So
Yeah, I think so.
in most logic classes, you don't ever get an exclusive or. You deal with this or. and we can make an exclusive OR by using some ands and nots. But because it comes up a lot in computers, I either need this flag on or this flag on, but I can't have them both on. We have this exclusive OR for that. And sometimes you'll need to do this. You'll need to check your user input. You need to work your way through your user input. We're going to want to start telling our user, hey, hosehead, you entered something wrong, right? And so we're going to need to be able to ask for ranges of our numbers. We're going to say, hey, did you enter a number and was it within my range? Or did you enter an integer or a double, right? We're going to be able to ask these questions and we'll be able to check them. So we have to start using the operators that let us do this. We okay with that? Mm-hmm. All right. And what we call these things are truth tables. What you do is you write the variable that could be true, and then you write your operator on it, and you apply the operator. So for a not, it flips the values. All right.
Wow.
And then here's what I did with the and table. It's weird, they're kind of, I've always done my truth table starting with truth. This book always seems to start with false. The author might be a pessimist. I don't know. Yep. And there's the OR operator. And that's what I did here, is I did what my two variables were, and then I looked at each operation. And so these are called truth tables. Good logic can help you get through your loops. All right. Here's the warning about the singular operators. If we run this code, this is going to give me x greater than 1. That's false. And then an x plus plus. So that's 2 is less than 10. That's true. And when I add those two together, that's a true is 1 and a false is 0. So an and between these would be false, because it's only evaluating the bits 0 and 1, 0 and 1. Where if I have this type of and in here, 1 greater than x, which is false, and 1 greater than x plus plus 1, which is also false, this would be false also. When I do 1 equals x, that's true, or 10 less than, greater than, true. That would evaluate true. This or would evaluate true also in those forms. We'll play with some of these.
So x plus plus means true.
No, x plus plus, this is a post-decrement or post-increment operator. Mm-hmm. So we look at the value of x first, and then we add 1 to it.
Oh.
Right, that's what our post-increment operators were doing. So we're actually comparing 10 is greater than 1, and then we turn it into 2 as soon as we're done.
Oh, I didn't know.
And what for me, this decrement operator, when you do an operator inside of a evaluation like this, you can sometimes get bit flags. That's why we might play with some of these. Just be careful in your logic. Use the doubles until we start using flags. All right. We're going to have a program that determines the leap year. We're in a leap year this year, right?
Yeah.
So a leap year is divisible by 4, but not by 100, right? So every century that should be a leap year, it doesn't become a leap year. Anyone know why?
Hey, can you rephrase that?
What?
Can you say that again? I wasn't.
Why do we have leap years, and why do they happen every 4 years, except when the year is divisible by 100?
That's a good point. I never really thought of that.
Anyone know of any old calendars or different calendars besides the one we use, like the Chinese calendar or the Islamic calendar for Ramadan? They're different calendars. I think the Judaic calendar is slightly different too.
We just had Chinese New Year.
How many days are there in a year?
365.
How long does it take for the Earth to go around the sun?
It's 365 according to the Gregorian calendar, at least.
What did you say something, Neffy? Or something?
365 in 6 hours.
Yeah, 0.2496. It's like not quite a quarter, but you're right, right. So the time it takes for the Earth to go around the sun is slightly more than how many dividing into even days. Over time, this pushes calendars out of whack. In the 1700s, they had to drop an entire month to line the calendars back up.
Did they really?
Because they weren't taking into account the quarter year. And so it used to be spring in April. All of a sudden now it's pushed back and it's beginning to be spring. Let me see if I get my direction right. Quarter forward, quarter forward, quarter forward. Yeah, in January. Right? And so when we learned to measure this a little bit better, we added leap years. But because it's not an exact 6 hours, it's 0.2496. Well, every 100 years, we drop one so that we don't start slowly getting off by that. Because it's 0.24 and something in the next decimal place, which comes 100. I worked with a gentleman who, the International Engineering Association has a standard for time. All of our computers, your GPS and everything, work by having clocks highly synchronized. Right? Your GPS satellites use atomic clocks that measure down to the nanosecond, and because of the general relativity warps space and time around the Earth, and they're moving relatively fast, the time that each one of those clocks has is warped, and so those clocks need to sync to the nanosecond and then to account for the space-time dilation they get to accurately count time. Time is an important standard for your computers to work.
Yeah.
They need to know what time it is on the network. When you communicate with another your computer, you exchange time, you exchange how long the time to live for your data packet is. For all of our logistics and computers things, they try to keep accurate clocks. We're going to have to play with our clocks slowly.
This is kind of why like Y2K was such a big fear. When the
No.
clock rolled over. Well, a part of it.
No. No, I was there for that, and my grandfather worked on code for it. The problem with that was they only used 2 digits for a date,
Yeah.
and so when the time rolled over, you could not represent the current date on the computers.
Oh.
And because a lot of the older computers that used these older code were in mission critical systems. There was a job advertisement in Germany right now asking for anyone that knew how to write device drivers for Windows 3.1. The German railway system is asking because they still use Windows 3.1 to run their trains. Well, think about it. You have a couple thousand trains running daily around the clock. How do you upgrade a system? We just had that happen a year and a half ago. We had a booking system in the airplane ports go down, and we had like 2 days where we had to go off. And everyone's like, we were running really, really old code. Well, to update the code for the airports, you have to update every airport across the world at the same time.
Yeah.
So code transitions are not easy.
It's very time consuming and costs a lot of money.
You can't do it.
I know there's ATMs out there still running Windows XP.
There's ATMs still running based off of Cobalt from the 1960s.
Yeah,
The banks are constantly asking, when systems run constantly and the system's working, you don't update it, and there are certain mission critical. So what you asked about Y2K it wasn't a fear. It was a justifiable concern, and we had systems that were going to break. People spent most of the 90s fixing it. The problem was trying to explain it to people that didn't use computers. They thought their computers would be infected, and it wasn't. Modern computers didn't have that problem. It was all of the systems running things in the background. And
I
so
actually heard there was some stuff that came from that. Very minor stuff, like some bank accounts had a little bit of money like moved around, like altered like funds and stuff like that, but it was very minor. There were some isolated reports of that.
I would love to see the details on it because, like I said, I lived through and worked through that.
Yeah.
I know of a power plant in Puerto Rico that had a minor issue because I was on the phones for support when midnight rolled over, and this guy in Puerto Rico was freaking out because he thought the whole world lost power. And I think it was a minor issue that it just had problems syncing back up to the grid, but they could manually sync it and fix the computer afterwards. That's the only computer problem I heard reported from it. But I watched loads of people spend a decade going out and fixing things. My grandfather wrote a lot of code for fire departments and police stations, and he went through and he had scripts that would update their databases and get it to work. But it's not the same as this type of error. This is inherent into how we do calendars. Now, what's going about is, even today, right now, to keep our calendars, the winds across the surface of the Earth cause friction to drag on the Earth, so our Earth doesn't always complete a cycle in 24 hours. Sometimes it's slower, sometimes it's faster, depending on the predominant direction of the hurricanes. And so we will add or subtract leap seconds every year now to keep our calendars
I
lined
didn't
up.
know that.
Well, now you do.
Yeah.
So, but for us, in a coding standpoint, notice how this becomes a logical way that we can use to figure out if we're going to have 366 days in a given year or 365 on the calendar year. Because we can take this mathematical formula that people have been using and we go, hey, what year is it? Can I divide it by 4 evenly? Remember, this is our remainder. Oh, what is this year? What year is it?
2024.
See, right?
Yeah.
Is it divisible by 4?
Yes. I mean, this is a leap year after all.
No. Go the other way. Right? Can you divide 2024 by 4 evenly?
Yes.
4 goes into 20 5 times, right?
Yeah.
And it goes into 24 6 times with no remainder. So, hey, we've got that. Are we evenly divisible by 100? No. Right, go back to 2000.
That was evenly divisible by 100.
Yep.
Because, double zero.
Was it divisible by 4? So it was divisible by 4, but it didn't have this not condition, so we had to throw away that leap year there, right? Or is the year divisible by 400 evenly? So what did we say it was? It was 365.246. So I guess every 400 years we get that 400th of a decimal place back. You see how they turned this into a weird math problem for us?
Yeah.
But we now have some logic we can use to check. And so we can take whatever the year is and we can fix our calendar.
We won't have to worry about seeing the odd leap year ending in 00.
Yeah, you will. You trust me, you have a homework problem
2100.
where you have to take into account leap years.
No, I bet in 2100 will be the next time we see that.
Let's see, 2100 is not divisible by 400,
No,
is
it's
it?
not.
So it doesn't get the extra one, which I think 2000 did, because it's 2000 divisible by 400. So
Yeah.
2000 was the nope. Oh, yep, do it anyway, right?
Yeah.
But 2100 will be the yep, nope. So, and that's the logic behind it. There's a nice little math equation we can do to work out what day of the week it is, and it will have to take into account leap years. You'll have to take into account leap years. Now, here's the deal. Again, Java has a great built-in date and time utility. Does all of this for you. Your homework problems on these, I need you to play with the logic. So in case, something better than Java comes around, like, let's see. We have Python, so let's say Rattlesnake 4.0 computer language or something comes out, right? Something different. And it's embedded in hardware, and you need to come up with the calendar for it. You know the logic for it. So Java's been around so long, all these tools are built in. Don't want you using the built-in tools. I want you playing with the logic. Okay? Yes?
Are these slides going to be uploaded to Blackboard?
They should be. If you're not seeing them in 3, I will, right when we're done here, I'll make sure that they're up here. Okay? Yeah. It could be just so much as I haven't hit them as available yet.
Yeah.
Sometimes it's that. I'll double check. Okay?
Maybe it's just missing. So I just wanted to-
And then I probably didn't hit the right button, but we'll fix it when we're done.
No problem.
All right, so the last thing I want to introduce in Chapter 3 are switch statements. We did a lot of these if, else, if, else, if, else. And what switch statements can do is they can create different cases. And in a switch statement, you will ask for the status of something, and then you'll compare different values. You will have a default if none of these values work. So it's a way that we can kind of make those if else, if else, if else, if else, else, if else, if else, ifs neater and more human readable. They compile to a similar thing when they come down. You can think of it as if this is this, do this, else if this is this, do this. So you can write these as if else ifs. And then in your final else is the default. It's just a more human readable way of doing that nestling. And it doesn't indent all the way over like your if else's can do sometimes. Coming across. And that's what I want to play with is switch statements here.
Jax is real fun.
Well, we're going to do a grade rule on them. So let's see. That's what I want here now. And we're good with that. I didn't want to do debugging. So I'm going to move over to the editor, and we're going to play with a case, switching case. So let me get our switch statements here. All right. So everyone get comfortable. Anyone need time loading in to the Eclipse, or are you there? Anyone not there?
I'm not there.
All right, I'll give it a couple minutes to get everyone there, and then we'll get started and start a new class, okay?
I'm in Eclipse and just not in the right spot for Eclipse. I clicked the wrong workspace, that's why.
I got the wrong Snapple. It's a watermelon based. My watermelon is sitting on this, so yeah, it's a little weak.
What was the one you were trying to get?
Not this. Oh, I did not want a watermelon lemonade. I wanted some type of tea, preferably peach tea.
Yeah. I forget, was in-class programs in the SRC or bin folder? I forget which one was the one that had...
You should not be going into the source or bin. You should be going directly into your workspace, and then it will read the source and bin underneath that.
Okay, I got it. That's what always throws me off.
All right, so I'm going to create a new program, and so a new class inside one of our existing in-class things, right? I'm not going to keep repeating that. And I'm going to be playing with switch statements, so we're just going to say switch. Examples. Anything to name it so you can find it, and we'll make sure we have a good public static void main. I'm going to make sure we have that coming across. Kent, you in a good place?
Yes.
Okay. Austin, you in a good place?
Not yet, I'm not pretty yet.
Okay.
Recent workspaces? No, it's not that.
So while we're getting here, let's sketch out what I want to do. I think I want the user to input a number between 1 and 10. And we'll make it a scale for something. What do we want to rate? What's a good thing to give us a scale out of 1 to 10 out of? Food, all right. So what are we rating it? Spiciness, its deliciousness, its aroma, taste, all right. So if the user enters 1, right, we'll have some word for this tastes like dog food, right? Right, some worst taste. And well, maybe let's say 1, 2. We'll make our 1 to 10 scale. Have some words for it. Okay? You think we know, 5, right? Bland English food. Don't tell my wife I said that. Right? And 10. I'm sorry, I'm doing it again, Sansi. You can.
I'll move.
No, well, and I'm just, we're going to make a scale from 1 to 10, and for each from the 1 to 10, you're going to have a phrase that describes it, right? So where the user's going to rate their food, and we'll turn that scale into some words. So I guess since we have user input, what do we need up top?
Import.
Import Java. Why am I typing in util? I always feel like I typo this thing. And there it is, the second time I do it. I must hit the I or L backwards and I don't see it. And I don't see it come down. Alright, so yeah, we'll want scanner at some point. Since Neffy reminded me that I didn't do good comments the other day, we'll do some comments, okay? So let's say we're going to rate our food from user input. All right, we'll at least tell ourselves what we're doing, and we're going to need to make a scanner object, and I can't do it. I cannot just get away from calling it input. I know it's unimaginative and not poetic, but there it is. All right.
Why are none of my source folders showing up?
Cancel.
Yeah.
Go to workbench in the upper right hand corner.
Can I try it from here?
No. I don't know why.
I'm in the in-class programs folder.
Ah,
Just
so
at the start of it.
so you're gonna, okay. So go to File, switch workspace, and go to Other. Browse. Go click on CIS 150
Yeah.
and hit OK. So select folder.
Just that.
Yep.
I didn't try that. It's the part that always throws me off is where in the folder do I click? Yeah, okay, we're
Yeah,
good.
you want to be on your top level. It takes care of the lower levels for you.
Yeah, that's what always throws me off.
All right, so we're going to ask our user, right? Prompt user to rate our meal.
Switch examples, I guess we'll name it.
Yeah, we're calling it switch examples. Yep. You can give it any name that helps you relate to it.
Yeah.
So, again, you don't need to do the exact same code as me here, but you get the idea. We're prompting the user for something, and then we're going to get the input. So, please rate this meal. We okay with the general idea? We okay? That's hard to tell. It's really dark out there, and
/ rate
and let's see.
our food from user input.
So we'll get input, and it's an integer, right? We're not going to do like 5.5 or 6.7. It's a basic 1 through 10. We okay with that?
Yep.
So integer rating equals input next lowercase n. Sorry, Next, int. And remember, this is a capital I here. Doesn't look it on my screen. I'm going to play with my fonts, see if I can get a better font. Alright, so now I want to take this and I want to have it do different cases. So what we're going to do is we are going to use the switch statement and we're going to use the rating as our case. The thing that we're going to go about. So our notice switch, and then in what we're doing different cases about, and then we'll look at the cases themselves. Switch, rating, and hopefully I'll get, yeah, I got both of mine. And so now I have this ability to talk about the different ratings I can get.
Hold on, I screwed something up.
So I'm going to put my cases for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then at the very bottom we'll put a default.
Yeah, I screwed something up. Let me go back for a second.
What do you need?
No, I just couldn't exactly copy what you were typing. Prompt user doesn't need it.
Hold on 1 second here.
Yeah, you were just going too fast. That's what I'm trying to say.
No, I'm trying to. Nope, undo. I'll split it vertically here. So the top of the code will be up here, and current code will be here. So I'm going to make a case 1. Well, what do we want to do with case 1? Well, we want to say system.out.
Wait, how did you do that?
Do what?
Make a second.
You don't need to do that. I just did it so you could see what was up above.
Oh. How did I do that?
You know, what I need to do is make this package explorer smaller. So what did we say? Like dog food. You alright with my horrible naming conventions?
Yeah, sure. That makes it sound appetizing.
Alright. And case 2. So what I want you to do is I just want you to do a case 1, case 2, work your way through case 10, and put some phrase out for it. And so notice how I'm doing case 1, system.out for my something. And case 2, we're going to fill our 10 cases, alright? You don't need to choose my words for it, right? Just be descriptive. We okay with that? All right. It'll take a few minutes. We'll fill all these out. And then we're going to run it, and I know there's problems with this. And I want to show you what the problems are so we can go in and then fix them, okay? Should have done a 1 through 5 scale, shouldn't have I? Right? That would have been a little more logical. Oh well, we bit off the large work now, so we've got to do it. You guys all right with this idea? Yep. And this is one of the things we like to do. We should like to do with code is just play with it. Like I said, there are definite problems with this, but I want you to see these problems. Let's see. Well, is cat food one step up above dog food? Like it's moister, it's more closer to tuna?
Yeah, I'd say probably. I wouldn't know. I've never eaten that.
I think I have.
Yeah.
Just my mom said it was tuna.
I mean, the cat food we got for our cats growing up was so high quality people couldn't eat it. We just never did it. little shits eat better than I do sometimes.
I'm going to get really sarcastic with some of my wording. I think 3 will be just like my grandpa.
Just like
This is the man that would cut mold off of bread or out of cheese because he grew up in the Depression, so you could never throw away food. So,
yeah, I've known those big people. Although to be fair, they do have a point. We need to waste less food.
again, don't tell my wife. 5 is going to be good, bland English food.
Why is your wife English?
A little bit.
I would say she's Scottish, but she doesn't.
She says she is English. Her brothers and sisters are Scottish because they were all born in Scotland. Father was Scottish. She was born in Scotland. Her mother, oh man, was she Scottish. Have anyone ever talked to like a deep Scots person? A Scots English? Like, can you understand a damn... my mother-in-law would call, "No, how the wee wings is going, like, Annette, it's your mom." Coming across.
They
So-
all sound like Scotty from Star Trek.
No, he doesn't have that type of accent. No, she spoke Scots English, which isn't even English. It's a weird combination of Gaelic and English. All right, so I'm almost there. I've got 6 cases. Let's see. I'm just making fun of people right now in my family. Well, you can do whatever you want on here. So when I was 5, I loved Dr. Pepper. It was a new soda at the time, and my aunt, we were out of soda, so she took soda water, read the ingredients off the bottle of Dr. Pepper, and we grabbed things from the cabinet to try to make the soda water taste like Dr. Pepper. She put a whole bunch of black pepper at the end of it, and then she handed it to me and said, "Drink."
Oh, that's funny.
So, see, we're going to make some comedy out of this, right, as we get through all 10 things. But then we're going to run it and see what happens.
Some people say Dr. Pepper's tastes like cough syrup. I think it's probably one of the better ones.
Moxie actually tastes like cough syrup.
Moxie's actually not that bad. I tried it.
I like spicy food anyway, so I'll put my spices in there. I'm almost there. I'm at
I'm
8.
not a Coke fan as much.
Out that print line.
I mean, we could make taste just like how Grandma used to make.
I'm worried about case 9.
Sweet something like that.
There. I have all my little phrases done. And then I'll make a default, which is just telling the user they didn't do a good number. Why is my default over? Alright, I think I have my cases lined up.
How many
Let's
pieces
see.
are we making?
10.
Okay.
Alright, it's worth running to see how this is broken, but let's see how it's broken. Okay? Is that fair? We got the idea that we have a switch, and then we have our cases for what's coming out of here. Something up?
No, I already ran it
You getting a lot of right? Yep, right. So good. So let's run it, and I'll give it a 5. And well, I get the good bland English food, and then I get everything else. Once it gets true, it just starts going, you're true, you're true, you're true, you're true. So we need to do something to tell it, once we get one, it's done. And what we have to do is we have to use a break statement. So I like with cases, because this is the thing I screw up with case all the time, is I like showing that it's a little touchy, right? So it recognizes 5 is true, but as soon as it gets that true, it's now switched so that everything is true, and you're seeing everything coming down. So what we need to do is when we're done, we need to tell this thing to break. And so we kind of have to add this break code to it. You will see, I will sometimes even write quick example code or reply to you, and I will forget this left and right. It's sometimes hard to code if you forget a break statement.
In violation of the Geneva Conventions.
All right, so I'll try running it again. And it breaks out. And we get a good choice. Now, realize that switch is an old programming thing. Came back in the C days to get rid of the if, else if, so that it could neaten it up. But in doing so, they created, I'm going to move this all to one screen here, sorry. But it created its own little syntax. It will spill down if you don't break out of it. So you need to contain these. I also, each of my cases, I will put in braces so that if I go back and edit, I don't have to worry about how many lines I get out of it. But you will find that when you have things that have to select a lot of values, this can be easier to read. Doesn't make your code run any faster. Doesn't do anything logically different than an if-else if. It just puts it in, I think, a better human readable form. Does that make sense?
You're going to put break at the end of every one of them.
At the end of every one, otherwise it will repeat everything else.
Retroactive.
What I like about switch statements is I have this default thing that I can do something if the user didn't enter something in the right values. So if you have all the values your user needs taken care of, that default on the bottom can go, come on, Jose, I said 1 to 10, right? You've got something that can take care of it. That, I think, is the big power of a switch statement, is you can start correcting your users now.
Would you rate below default? I didn't get to put that in yet.
Not a good number.
Oh, so how do you type it in? System. Oh yeah, because I was busy doing something else and didn't see it.
So the default, notice I had all of my valid stuff taken care of. And you can get those cases to be logical comparisons. We'll be able to do them with strings later on. There are many different things we can have the case statements go through. I love building menus with the case statements, right? Choose option 1 through 9, right? To speak to, no. They're good for menuing systems because they act like a menu system. All right, I have finished chapter 3 completely. I'm going to stop here today. I'm sorry about the short days and sorry about missing. Read chapter 4. I will get all the programs up for chapter 3 and chapter 4. We'll give 2 weeks on those. If you use anything from chapters 1 and 2 you want to resubmit or you need to submit, fine, let me know, right? If you're having any problems submitting them, I'll give you space for them. Anything anyone need from me right now?
Wait, that's the end of the day?
I submitted one of my assignments 2 minutes late.
That will not affect anything.
Okay.
Yeah. The due date is really for me to make sure that I can start having them in
And if some things are late and I'm getting to grading them, I look at it this way. If I haven't looked at it and it's in my pile, it's in my pile. If you're still trying to get things into me, that's fine. Yes.
Can you reopen the Hello World? I don't know. I submitted mine, but for some reason it like didn't fully submit.
Was this the first in class?
Very first.
First in class?
Yeah.
Let me see here. All right.